Okay, hello, this is Miss Cash. I'm hoping to help you understand what's going on with today's assignment, which is about graphing systems of inequalities and being able to solve those systems. So the first thing we're going to do is we're going to take a few notes. We're going to title them Systems of Inequalities. Inequalities, we've looked at systems of equations, but take a second and try to tell a neighbor what you think an inequality is. So hopefully you chatted for a second, and a system of inequalities is when they are not equal to each other. They're less than or greater than. That's a system of inequalities, two inequalities. So that's what we're going to look at today. And in an inequality, we have a different type of solution. A solution is a whole region on the graph. Anything in that region satisfies that system of inequalities. And we're going to actually see how you use that in the real world tomorrow. Also, what we need to know is if you have a greater than symbol or a less than symbol without the equal, then you have to graph it as a dotted line. If you have greater than or equal to or less than or equal to, you graph it as a solid line. Why? Because it's actually equal to the line in that point. If it's greater than or equal to, less than or equal to, not equal to the line if it's a dotted line or a dashed line, you might say. So let's just solve one system of equations here. Let's do one example. Again, these do not have one single point as a solution. They have a whole region. So let's start with y equals, not equals, let's say less than or equal to x squared. And then let's say y is greater than x plus 2. So we have a parabola and a straight line. We're going to graph them both. We're going to follow these rules that I wrote for you up here, and we're going to shade the answer region, as I was saying. You probably did this back in Algebra 1, maybe not with parabolas, but you did it. So let me make sure this is showing up on our graph. Great. And we're going to graph this. So we're going to start with using the calculator just to get the idea of the graphs of the lines, and then we'll decide how we're going to draw them on our graph. So y equals x squared. I could use the calculator, but I bet you know that y equals x squared is our parent function for a parabola. It goes through 0, 0. And remember the pattern: over 1, up 1, over 1, up 3, over 1, up 5. For a parabola. If you need to use your graphing calculator to do that, you may, but you don't have to if you know that pattern and can get some exact points without the calculator. Now, notice that I drew that in as a solid line because it says less than or equal to. Then finally, I need to deal with that less than, and less than means our points should be less than these numbers here. Well, how do I do that? Well, if I am starting right here and I go less than this graph, it means below this graph. So I've started a point on the graph and come down. So anything below that graph actually counts as less than. And so what I'm going to do is I'm going to take myself a colored pencil and I'm going to shade in everything below that graph. I do it in colored pencil because it's light in color and you can see through it. Doesn't cover up everything else, but we know it's there. So everything below that graph is a solution to just this inequality right here. Now we're going to add another inequality. We're going to add the y is greater than x plus 2. Again, if you remember mx plus b form, our intercept is right here, the plus 2. And then the slope is 1, so you're going to go over 1 up 1, over 1 up 1 for each point. I'm putting those points on the line, but I'm not going to connect them. I may get a straight edge to help me draw that line straight, but when I go to draw it, I'm going to draw it as a dashed line, not a solid line. Why? Because it says greater than, but not equal to there. So I'm going to draw a dotted or a dashed line through these points. So that is my line for y is greater than x plus 2. And I'm going to find a different color to shade with. Maybe a nice orange here. And greater than. Greater than means bigger than. So if my y value is 2 here and my y value is 3 here, above the line I have bigger points. So I'm going to shade in everything above the line. I'm not even looking at the parabola right now. I'm just coloring down to the line. And then my solution region to the line is everything that's orange. My solution for the parabola is everything that's blue. My solution for what we call the system is where both of the colors show up. So this region right here and this region right here are our solution regions. We have two solution regions, either over here or over here, where they're both shaded, both blue and orange. So that's what you're going to be working on today. Tomorrow we're going to apply this skill to some real world stuff. If you finish up with this, you can work on your review preview and use the homework help on cpm.org if you would like as well. Please be productive today and use your time wisely. See you tomorrow.